The setup I have is port 1 connected to port 2. I have a long cable here. I actually have a switch too, so my port 1 can either go to port 2 or it can go to a power sensor so I can measure the output power. And then I have a signal generator, VXG in my case, connected to the source X in. And the references are locked to the ref out of the VXG goes to the ref in of my network analyzer. So if I come to the network analyzer here, let's start with preset. I switch it to S21 to see my through cable. Let's limit the frequency to 20 gigahertz because my switch and cables are all SMA. And the sweep you had in that example was CW time at 10 gigahertz. I will turn external reference on to lock it. And this doesn't mean necessarily it's locked. I have a macro set up that runs this key to check on it. Now it says locked, but if my cable was loose or something was wrong, this would say unlocked, but that's the only way to test it. There's no auto detection circuitry. And if I put a marker there, minus 4 dBm, that's the loss in my cables. Let's add a new trace and measure the B power and put the marker on. And it's around minus 19 dBm. Let's make these larger so it's easier to read. Okay, minus 19 dBm, which makes sense because the default power is minus 15. With 4 dB cable loss, I end up reading about minus 19 there. So now I'm going to switch in the VXG. So I say setup, internal hardware, RFIF path config. I go to external, I say apply. So now I can see nothing is hooked up, but because that's my VXG is not on. So if I come here, and this is my VXG, I will set it to 10 gigahertz. I will set the power to minus 20 dBm, and I will turn this on. And let me turn this mod off. So my gain is the same gain. I'm reading around minus 29 dBm of power. And so if I go into the data sheet, this is page 53, there's a spec that says external source input and test port typical. There is a gain. That's the 17 dB you were seeing, 16 to 17 dB. That is the number here, 16 to 27. I'm not seeing it. I'm actually seeing a 9 dB loss, but that's because this is with minimum attenuation. So if I come in here and I change my source attenuation to 0 for that main attenuator and the P1 attenuator to 0, that's two sets of attenuators. Now this is minus 5. So now my minus 20 has become minus 5. And I have a few dB loss in the cable, so that's this number approximately. I mean, we don't have calibration, but you can see that changes. So if I make this, for example, minus 15, this went up by 5 dB. It's about 15 dB and a couple of dBs of loss in the cable. So that's the 16 to 27. If I am not locked, if I turn this external reference off, like pretend I'm not locked, it doesn't really change here. I still see the signal. If I'm running at 100 hertz, which was the narrow bandwidth that I think I saw in the example, then I completely lose my B. It's not like I don't see any little change. It's just doesn't pick up the signal, but at the wider bandwidth, of course, it does. I mean, though the correct way is, let's say, go to the narrow one and be locked, and then you can make the measurements.